Collaboration Program. I'm going to be your MC for today's webinar. So please note that today's webinar is being recorded. Recording will commence in a few moments' time when Elisa hits the magic button. So sometime in the next week or so, the recording will be made available for viewing on the IWN Knowledge Hub. So if you're short of something to do on your 4-day weekend coming up, get into the IWN Knowledge Hub. There's plenty to view there. If you're unsure about how to get to the Knowledge Hub, we'll post a link to that Knowledge Hub in the chat during the course of the webinar. So I'd like to begin with an acknowledgement of country. So we acknowledge the traditional owners of the lands and waterways on which we live, work and play. We recognise and respect their care for country for thousands of generations. We acknowledge and respect the significance of their cultural and heritage beliefs, and we'll walk together with them to recognise their spirit, people and place. We acknowledge the impact of the actions of the past and commit to a future of healing and reconciliation. We acknowledge the need to be brave and to make change to realise this commitment. We pay our respect to their elders, past, present and emerging, and extend that respect to First Nations elders and First Nations people present in the webinar today. Thank you. Now, I know we've all been working virtually for what seems like forever, really. So I'm sure you're across all the usual courtesies that apply, such as please remain on mute and also mute your camera to preserve bandwidth. Today, once again, we'll be using Mentiboard for questions rather than the chat. So there is a link to the Mentiboard being posted in the chat, or simply just type in menti.com into your smartphone or your browser. It's really easy to use. Just type that link in and use the code 44737348, and you can post your question on the Menti Q&A board. We're going to put that code in the chat in a few seconds' time, and I think Elisa's doing it already. Questions are ranked on their interest. So today it is a popularity contest, so you can upvote questions in the Menti board just by simply clicking the like symbol to upvote that question that interests you. Questions will be addressed at the end of the presentation. Just want to ask, please don't use the chat for questions because they often get lost in some of the wonderful conversations and banter that occurs. So please do use that Menti board. Now, I'd like to introduce our IWN Asset Management and Optimisation Program Leads who will host today's session. Callum Tate, who's a Mechanical and Process Engineer at Tas Water, and Prith Roy, Electrical Engineer at Yarra Valley Water. Guys, it's over to you. Thanks.
Thanks, Jason. I'll just get straight into it, I think. I'll introduce Dane, our presenter for today. Dane Boers is a founder and lead engineer of Modla. Spent 15 years in many asset-intensive industries and is a subject matter expert in analytics, value frameworks and asset management. So Modla itself is an asset modelling, a virtual, oh God, I've completely screwed that up. It's a model for linear assets that we can program works to provide preventative maintenance in a much more streamlined manner. The idea here is we can have several different assets like already pre-built, and you can apply them to your own assets once you sign up. I think I've completely butchered that, so I might just hand over to Dane and let him clean up my mess that I've just made.
All right, cool. Okay, let me just get started real quick. Everyone can hear me okay? I'm coming through clear. I'm going to share a screen and just kick into it unless anyone else from the IWN want to say anything before we get started.
All good, Dane. Loud and clear at my end.
Awesome, thank you very much. All right, can everybody see this screen coming through here?
Yep, that's great.
Yep, that's perfect.
Great. All right, well, thanks for the introduction and thanks very much for having me to present to you today. The agenda for this webinar is up on your screen. We're going to talk a little bit about sort of overarching need for knowledge sharing and collaboration within the water industry. We're going to look at our proposed solution. We call it knowledge first architecture. And then we're going to dive into the particular trial that we did with IWN over the kind of last year and a little bit. We're going to go through at a high level what we did, what we built, and what some of the outcomes and learnings were. And then we're going to step back into the broader architecture and talk about next steps and where to from here around sharing knowledge, data, and collaboration. We're going to have a section for questions at the end, and we're also, during this presentation, I'm going to ask you to fill out an expression of interest form that I'll post a link to in the chat, and I'll talk about like what that means in terms of forming our forward plan for this whole piece. So let's get into it. All right, so from recent water industry conferences and events and discussions that we have with our clients, and essentially the general direction that I'm getting from industry, it's pretty clear that most utilities understand the need for collaboration, knowledge sharing, and data sharing. But there's different types of information and knowledge that we can share. So when we talk about raw data, what I mean is things like costs and failure rates and likelihoods of safety events and all of that kind of stuff. When we talk about asset knowledge or knowledge capital, it's really the current understanding of your assets. How do you understand how they work, what affects them, what different tasks and interventions and things you can do to them, what strategies and approaches you would apply to managing them. When we talk about sharing business process, it's really how does your utility or your organization go about building asset management plans, forecasting costs, understanding and managing risk, spares, work execution, etc., etc. And lastly, how does your business identify new insights, learning, and improvements? If all the utilities had the ability to share this type of information within and across industry, it would be pretty cool, right? Well, yeah, but how? That's the question. I don't think many of you would dispute the need. It's really just a question of how do we do it? And so the answer is Lego. And it's not exactly Lego like this, but you'll see in a minute how if you think about it, this problem in terms of building blocks, it makes it a lot easier to solve. But first, before we get into the proposed solution, I'm going to post a link into the chat. Let me just pull it up now real quick. Yeah. Hopefully that's come through okay. All right. And it's a link to an expression of interest form, and you may have already filled this out as it was sent out by IWN and Modla over the last kind of month. And what we're trying to do is gather the information of the people and utilities who are interested in establishing a shared knowledge base, which we'll discuss more in the next steps at the end of this presentation. In the form, you can nominate asset classes that are most topical for you and your business, and this will inform the plan of attack, which asset types to prioritize, etc. So far, there's been around 20 utilities that have already expressed interest. And if you haven't filled it out, please fill it out during this presentation, and we'll look over the results at the end if we have some time. So much appreciated. All right, so how does this need relate to Lego? Well, each of these elements are complementary, but they're independent and shareable. So they connect to each other, but you can share them and improve them independently in their own little silos. So starting from the left and with an asset-centric view, the data coming in describes what assets you have. Everyone knows the first step towards great asset management is understanding what assets you're managing. And then you combine that information with what you actually know about the assets. And I'm not talking make, manufacturer, age, and condition. That's the data that's fed in. I'm talking about how well does your business understand how this asset works, really, how it performs, what you can do to it, what you can't do to it, and why. What does condition mean? what environmental and operational parameters change how long it lasts. This is the knowledge piece that I'm talking about. And unfortunately, the current system for a lot of utilities for capturing this critical information is usually a person or people, the senior engineers or subject matter experts in your business. And this isn't a sustainable solution. So once you understand what assets you have and combine that with what you know about them, typically what happens next is we have one or more processes that run off the back of that. These can be calculations, decision trees, optimization techniques, whatever. The point is your business has some way that it goes about generating asset management plans, programs of work, budgets, etc. And this is also useful information to share and compare with other utilities and see how they go about building their budgets and AMPs and strategies and so on. Lastly, sharing how do you view, learn, display, implement and improve the outcomes from your process. And being able to compartmentalize this and share that is also of really good value. So splitting out these building blocks enables us to build what we call a knowledge-first architecture. And we call it this because there's so many use cases for asset knowledge, and there's no one particular end goal. Rather, it's an architecture that we can build out and improve according to our business needs and use cases. But it all starts with understanding what we have and what we know about them. If we compartmentalize the information and data and knowledge in each block, it makes it really easy to share, collaborate on, and improve. So let's look at an example. Can everyone see this? I'm just hoping I didn't share my window and instead I shared my screen.
That looks good. It's looks like a mural.
Yep, I'm going to zoom in, so don't worry about putting your glasses on. I'll zoom in. Alrighty. So what we're looking at here is an example knowledge-first architecture, and I'll explain the kind of different elements of what I was just talking about and how it all interconnects. Firstly, over on the left here is your input information and input data. Now, I'm just talking about this block right here. Typically what happens is businesses have, you know, their EAM systems, their CMMS systems, GIS's data lakes, where all their current data exists that we're going to be drawing from to inform the process to the right. The first block here are all the different asset models. And I was just talking about this, but this is the domain of the subject matter expert, the operators, the maintainers, the engineers, the people who have specific domain knowledge about each of these asset classes. And the contents of these models contains things like components, failure rates, events, tasks, different decision logic that they might use that's asset related, conditional information, and so on. But the idea is that this is what you know about a particular asset class and how you understand it. And when you combine that with the data that you have around your actual assets, you derive a representation of what you have out in the field and what you understand its condition to be and the environment that it's in and the remaining life and all of that kind of stuff at this point here. So this is your current view on what you have and what its current situation is. Okay, and all the asset classes, that they all have their own knowledge base that gets combined with the data to generate this. So this is almost representative of an asset hierarchy. Once you've generated your current understanding of each of your assets, only then can you apply some business logic to it to determine or answer a question or solve a business need. And as I said, it can be anything from calculations, decision trees, implementation of particular standards or policies, whatever you want. It's essentially a block of code that runs over the top of that information to generate an outcome. They can be risk-based, value-based, condition-based, and this really depends on your business maturity and you know, if you want to change these blocks and do things differently, you can. So building it out this way means you could do things like, let's take switchboards, for example. If you don't have very much data or information on switchboards, you may say, as a business, we're taking the decision to just perform maintenance and capital tasks in line with standard A, B, C, D, E, some standard that's off the shelf. I'm not going to do anything more technical than that. I don't have the domain knowledge or the data to feed something more complex, so I'm just going to align with this standard. For different asset classes, you may have different levels of information and understanding, and you may be open to doing things a little bit differently. So you might apply an optimization technique to determine capital and maintenance task frequencies and things. For PRVs or for inlet screens, you may manage them differently, like with risk thresholds, or like use a program of work solver like we're going to talk about in a second. Essentially, you can apply whatever business logic you want as long as you can compartmentalize it. Okay. These solvers or processors provide outputs that may feed into your asset management plans, your budgets, your replacement programs, and everything else that comes out of this is captured as a different scenario. And the scenarios can be in use, like in anger used ones, or they can be kind of scenarios generated to compare different results and identify improvement opportunities. The outputs could be interfaces to different systems, dashboards, documents, or whatever you want. Okay, so we'll come back to this a little bit later, but hopefully this all makes sense. Again, I just want to reiterate, combining your current data with your current thinking to get a baseline of how you understand your assets, and only then apply your business rules and things over the top to generate the outcomes you need. Cool. Oh, one thing I didn't point out really quickly is that because it's separated and compartmentalized, it allows you to incrementally improve each of the different blocks, right? So as your learning and thinking changes around a particular asset class, you're adding and constantly evolving the model content for it. And as your business process changes, you can switch blocks out for other blocks and change the methods you want to use, moving up in maturity from, again, condition-based to risk-based to value-based, and it allows you to do it incrementally instead of doing it all at once. The other thing to note is that a lot of tools and software that are out there, they will solve a particular business problem and implement one work stream from left to right. So you're stuck with the approach that they use, and you're stuck with the framework that they use up front in terms of the inputs that it requires. And we all know that not every part of the business is solved the same way, and we don't have the same maintenance strategies for everything, and we may want to be a bit more flexible with it, and we don't want to have to buy new tools and go through all the change management and stuff every time we want to change the way we do business. So having a framework that allows you to incrementally improve is really, really useful. All right, so jumping into the trial that we did with IWN. The objective of this trial was to build a program of works solver block, which is this middle piece here. The scope was to build a repeatable approach that could be used by any water utility to take their data, combine it with an asset class model, in this case it was sewer mains, and generate from it one or more programs of work. As part of the project, we facilitated the requirements of this solver block with workshop attendees, and the requirements are up on your screen. So it was to perform an optimization function, generate either manually or automatically practical packages of work, it had to consider both budgetary and target/service measure constraints, and it had an optimization timeline of 5 years, but you could choose 10 years or 15 years program generation. The data that came out of the solver needed to be able to present risk and cost implications, lay out the prescribed program of works. It must be able to report on different scenarios if you wanted to change some of the parameters, and do it in multiple formats, from like documents to CSVs to dashboards and Power BI things and so on. So we built this solver block, and to validate the results, we also facilitated a sewer main asset model. Now, the sewer mains model that was developed as part of the project was only built to illustrate the capability of the solver. So the solver was the primary focus, and therefore there's a few caveats to the results. One is that the content of the model that we built for this project was based on SME assumptions in many cases, which is not to say it's bad, it's just there's room for improvement there. We only modeled 4 maintenance activities, so replacements, relines, CCTV inspections, and high pressure cleans. And the failure rates were informed by SME opinion and white papers, and we didn't do any detailed failure data analysis as part of this model build. One other thing to note is that the sewer mains model only considered gravity sewer mains, and all of the content that was facilitated in this workshop's now hosted on assetwiki.org, so that any SMEs that are interested can go on there and further contribute to and improve the model build. Then, after those 2 elements were built, we fed the model and program of work solver with data from 3 utilities, namely Barwon Water, Melbourne Water, and Gippsland Water. And then we compared the results with their current methods for developing program of work for relines. And here's what the results look like. So I'm going to just talk you through them really quickly. For Barwon Water, there's a big difference between what's in their current program, which is shown in the red, versus what the program of works solver is proposing, which is shown in the green. This difference is expected because they're different approaches. So Barwon currently uses a rules-based / decision tree approach for their little solver block that you would have in that architecture. Whereas what we used as part of this project was a value-based approach. And another way you can think about it is their rules-based approach is primarily focused on preserving condition, where the value-based approach takes into account consequences of failure, and it may recommend some sections of pipe for reline that may not be in the worst condition, but they are higher criticality or higher consequence values. There was a decent overlap in terms of the worst condition pipes were picked up by both their rules-based approach and the solver that we built. But there are some differences, and it's primarily explainable by the difference in approach. It's neither one's right or wrong. It's more what's the objectives of the business. If it's to maintain condition, then this would be the set that you would look at. If it's to maximize value, then this would be the set to look at. So for Melbourne Water, it was very interesting. They have a lot of large diameter pipes and no proactive relines without a condition assessment. The program of work solver that we built pretty much agrees with this and says nothing on your network is cost beneficial to replace early without a further condition assessment, because just of the size and costs of doing such work and consequences, essentially. Gippsland Water's dataset was also pretty interesting. There was a high level of overlap between what the program of work solver recommended and what they currently did. A lot of the red that you see here in the sections that they're going to replace that we didn't identify were opportunistic replacements. So you're already going out and replacing these 47, let's say. Let's replace some of the ones that are around it while we're out there. It may not be cost beneficial to do so, but we're in the area, and from a delivery point of view, we'll just take the opportunity to do those. But yeah, there was a few here that we identified that they haven't considered as well. So overall, the results that came out, they made sense. They show a difference of objective, a difference of when the objectives are different. Like there can be some variance between the assets that you're identifying. And as always, it's dependent on the quality of data and quality of model contents and so on, which will only improve over time. All right, some of the learnings. Firstly, it was evident that not every business is ready to move to different approaches like the optimization solver that we built. The different approaches need different like data sets to feed it and a certain maturity of the business. So you need to already be thinking about quantification of risk and so on if you're to move to some value-based optimization techniques. Also, the outcomes may not be immediately achievable for the business. If a solver recommends that you do X, Y, and Z, you still need to consider deliverability constraints, resource requirements of implementing that, etc., etc. But it does highlight the potential future improvement opportunities. The second point here around decision trees versus optimization methods, pretty much all the utilities that we talk to are currently using some form of decision tree to determine what their programs of work are. The optimization methods that we use, there's some theoretically you can get a better result if your data is accurate and the model contents are accurate. But the downside is optimization methods are a little bit less transparent because they're a mathematical operation, right? So it's almost a little bit like trying to trust the black box and trusting the mathematical process. It's harder to communicate to regulators and to your stakeholders and bosses and so on that this result is right, because it's not transparent like a decision tree where you can see this is exactly what I did and why. The optimization might recommend a combination of tasks that make sense if you're trying to maximize value, but otherwise it's a little bit, you have to really dig into it to understand what's going on. So there's a little bit of a higher technical ceiling as well. And the last learning is we should probably focus on the asset knowledge first. All of these optimization and fun things to do in the right-hand side of the process are really good, and they're interesting, but we need to get the basics right first. And so what I mean by that is if I go back to this diagram here, all of these things are really cool to have and play with and try and understand better ways of doing things. But I think where the industry is at the moment is we really need to get this baseline knowledge standardized, captured, shared, and improved in order to enable an architecture like this. Okay. The other thing, just before we move on, that I'd like to talk about is the contents of these asset models, like what goes into them. And the way we determined what goes into them is we considered all the possible use cases that we can think of over on this side and essentially worked backwards and came up with a list of things that we need to know back here in the process. And so what that list looks like is up on your screen here. And so we're talking about next steps. We're proposing to facilitate an open source industry-wide library of asset models that contain all of this stuff that we need to feed a knowledge-first architecture. Information around components and failure modes, failure rates and distributions, different tasks, inspections and interventions and things, what they look for and how likely they are to detect certain faults, events, costs, and one of the key bits is this subject matter expert decision-making logic. So how different environments and operational contexts and conditional factors affect the assets, and the relationships between all of this stuff. So one of the reasons why James Good's in this meeting, the WASA rep, is because we believe that an open source industry-wide knowledge base would be really beneficial to industry, but I think it should be an Australia-wide and New Zealand-wide and anyone else that wants to get involved. So like it should be sponsored essentially by the highest level industry body that we can get on board. So it'd be good to get everyone's thoughts on the need for a shared knowledge base, how we go about facilitating the information, any ideas that you have in this space, etc. I'm going to open it up to questions right now, and then we can go through the results of that form in a second and see which asset classes are getting nominated as the highest. So I'll stop there for a second.
Wonderful. Thanks so much, Dane. And yes, we do have a number of questions actually that have come through on the Menti board. So thanks everyone for posting those. The most upvoted question is, could you talk to us about Modla and how it would work with utilities that may be transitioning from preventative maintenance models to reliability-centered maintenance and using IoT or condition monitoring devices?
All right. So there's a few sort of sub questions in that.
Yep.
The first one is that the models that we're proposing to build and that we've already built already, we already have a handful of them that we built for quite a few utilities. They're compatible with all different business approaches. Now, the content of them is very much like an RCM type foundation. So there's all the failure mode level detail all the way up. But in order to transition, you don't actually need to be at, let's say, your whole organization doesn't need to be at doing RCM on everything in order to leverage these models. You can use them for really basic stuff like OEM recommendations through to actually doing some analysis to try and optimize where your maintenance should occur. Now, IoT, how IoT fits into the piece is IoT for, and I'm assuming you're meaning things like vibration sensors, like data from the field coming back. Essentially, that forms part of a condition assessment. So it's conditional data like high temp, high vibration, you know, low thickness measurements, whatever your sensors are that are out there. That comes into the model as condition data, which essentially adjusts the forward-looking failure characteristics of the assets that you generate, and therefore any decisions that you make off the back of that when it goes into the process piece are reflective of that current condition that's informed by your sensors and so on. So it's treated exactly the same way as like visual inspections and other condition assessments. You're understanding what's going on with the asset right now, and if you reflect that in your current representation of the asset, then any future decisions will be reflective of that as well. I hope that answers your question.
Thank you. And whoever posed that question, if you need any more information, just pop another question in, or just raise your hand, and we'll. There's about 30 people on the call, so sure, just raise your hand and turn your camera on, and we can delve deeper into that. With submissions to the ESC and potential cuts in certain CapEx and budgets, how does Modla handle the change in boundaries, priorities, risk, and criticality in relation to cost?
Okay, so it's a good question, and the answer is partly how does your business want to handle that? Because we have the capability to run the solvers that we have at various levels in your business. So we could start off with running solvers at individual assets or asset classes or asset fleets, all the way up to kind of your entire asset base. And so when you're talking about cuts, obviously the way the models are built are to take into account not just the costs, the material costs like labor, parts, materials, and so on, but the consequence costs and like the risk costs and where you're going to with criticality. So monetizing safety risk and environmental risk and so on. But when you're running that analysis at different levels, what you're talking about in terms of cost cutting is essentially a constraint. It's a budgetary constraint over multiple years that you may have, cutting the costs by 10%. And you can run different scenarios to determine like what the impact is in terms of risk profile and value that you're going to get from that cost cutting. And so when I say it's partly up to your business, it's like, do you want to cut costs on particular activities or particular asset classes, or just across the board? Will determine where you run that, where and how you run that analysis to figure out what the best balance is.
Okay, thank you. Prith, did you have anything to add? You've turned your camera on there.
Yes, I did. Thanks for the answer there, Dane. I did ask those two questions earlier. The first one was with IoT condition monitoring. I mean, yeah, we've spoken before. I know a bit about Modla, but it was more about there's a lot of tech out there right now that's always monitoring. There's live monitoring, 24/7, nonstop. I'm just thinking, is that something you've thought about now that we've got this kind of, IoT sensors, electrical signature analysis, all these things that's constantly monitoring? How does that fit into the model? Do we need to run the models every time there's a change, or does it run in the background? And yeah, have you any thoughts on that, I guess?
Okay, so the way I see it is the data that's coming from the field should live somewhere, whether it's a data lake or like historian software or whatever. But there's a piece that sits between the sensor and the analytical model input, and that's really understanding what the sensor or sensors are telling you and what that means in terms of the condition of the asset and so on. So as an example, let's say you've got a temperature reading that's coming in and it's living in some other system. Because we're a knowledge first architecture, you need to know what either levels or thresholds or conditions need to exist on that with that temperature reading that will have an effect on the asset. So if you said if it runs over 110 degrees for more than a day, then we're going to get degradation of the oil in the bearings on this pump, and therefore it's going to reduce its life by this much. Now, some of the companies, the IoT companies out there, use machine learning and AI to try and figure out where that balance is, but you need to understand that piece before you can say, all right, now I'm going to, because that threshold has been hit for a day and it's over 110 degrees, that would come into our model as like a flag to say high temp has been detected and therefore degrade the bearings lives, degrade these things. But you really you can't just take a sensor input and do something with it. It's not a black box. It's an execution of your current understanding. And so you need to articulate that first, and then it can be considered as part of the whole process.
Yeah, no, perfect. It's a journey. Yeah, it's not just something you buy off the shelf, install, and then off you go. Yeah,
exactly.
Perfect. Yeah. Thanks.
Thanks, Dane. Thanks, Prith. Okay, next question. Is it possible to combine more than one solver across one asset group?
Yes, and you can do it in multiple different ways. So if I quickly reshare again, let's go to this screen. Yeah. All right. So you can have multiple asset groups feeding into a single solver. Like let's say you wanted to do something that optimized maintenance over a whole water treatment facility all at once. You could have all your water treatment facilities assets all going into a single solver to do that. And the reverse is true as well. So you can have, like here on inlet screens, for example, you could have that feeding into multiple solvers. Maybe one of them is used in anger as part of the AMP and the budgets and so on, but maybe the other one is more of an exploratory solver that we're looking at moving from our current condition-based stuff to a risk-based approach, seeing what that looks like and comparing them in, like, another system or spreadsheets or whatever. Essentially, it's running this scenario using a different solver for you to look at and understand, but it doesn't tie into the AMPs and the budgets and the like BAU process yet. If then you decide that, oh, this is really good and we're getting better results out of this than what we're currently doing, you may want to switch over to this one being in anger and having the data feed go down the different path. But you can connect them up to different approaches. Typically what we do when we run projects and things, for example, like this one here, we run it through multiple solvers, like all of the sewage pump stations, for example, to see what does it look like if we execute our current strategy, what does it look like if we run a value-based optimization, and what does it look like if we run a decision tree that we're looking at improving, and then comparing them and learning from them that way. So the answer to your question is, yeah.
Excellent, thanks, Dane. A similar sort of vein, are there standard solvers that Modla recommends by asset type?
We have a bunch of standard solvers that we've developed already. It's not really linked to any particular asset type. We have ones that optimize according to value, ones that run whatever strategy you pass it, ones that run to fail, like the program of works one that we just said, but they're set up to be generic. So this program of work solver that we ran with sewer mains, you can connect that up to any other asset class and provide it a budget and targets, and it will go through and test the different plans and develop programs for those plans, replacement programs and refurbishment programs and so on. So they're designed to be modular and universal and not tied to any particular asset class. Really, this, in my opinion, the selection of the solver in this architecture depends on business maturity, quality and quantity of data, and what you can realistically deliver off the back of it. You don't really want to pick any non-fit for purpose solvers, but being able to play with them allows you to identify the improvement opportunities. So in general, no, there's some ones that we use for everything, which is like the as is one, which is what you're currently doing, the value optimization one, but yeah.
Okay. All right, thank you. And the last question we've got on the list here is from Steve Beckwith from WA Water Corp. Said, have you seen any instances of asset models, and in brackets mathematical digital twins, where operational models are shared back with asset renewal / replacement frameworks?
Okay, can whoever asked that question just elaborate a little bit more for me?
Steve?
Yeah, sure. I'm just getting myself unplugged.
Good on you, Steve.
Hidden away. Where I'm coming from with this one is that from a perspective of model sharing across silos within your organisation, every part of the business has their own spreadsheet, has their own model that have in different places. We have, operations. We have an optimization algorithm associated with like an aeration or an anaerobic digestion model or some part of the business, for example. What I'm looking for is a model sharing enterprise architecture where you've got solvers and models shared across the entire organization, where you're able to do that kind of sharing of Lego builds of your models, then with the solvers, which can be used at all different parts of the business, and you've got that consistency in models and consistency in solvers as well, and I'm trying to find out if that what you're looking at here supports that kind of concept.
So yes, but just to be particular about what we're talking about here is different parts of the businesses will use different solvers to get to their outcome. So finance might use one, capital planning one, maintenance might use a maintenance strategy solver, etc. But in terms of how we see it, the asset model, which again contains the current thinking around that asset class, should be the single, like there shouldn't be multiple copies of the same asset class models.
Agreed, and that's what I'm looking for. And that concept in itself of a model, a mathematical model associated with, let's say, a sewer main, or we can talk about an aeration area of a treatment, whatever the case may be. This is the think of which is the core issue, not so much around cross organisations, but within the business. Is if you've got too many models across that, so that kind of, and trying to, it's possibly for an offline thing. I can talk to you separately about whether you're looking at here or trialed has that concept within an organisation. Because I was worried when you said, well, we just came up with a model here for a sewer, and we've actually got that talking to our renewal and replacement people, that you had a siloed viewpoint again.
Yeah, no, so it's definitely like one that's meant to be, in terms of the sewer mains one, we facilitated it with the players in the room for this project, but it's designed to be like expanded upon as other utilities provide their inputs, their data, their context, their failure modes they're seeing, and so on, and their thinking, and we just keep building on it. But one thing to note is that it's the mathematics part of it isn't done in here. Most of the mathematics are done in the solvers, but there may be some like analysis that you do to inform the content of this model, if that makes sense.
It does. Yeah, understood.
So let's say you analyzed your failure history and failure rates, and you sort of said this is how long they last for, and this is how all of that, those type of learnings, they all go in here. So they're all informed by, but they can be informed by analysis or white papers or opinion or whatever your current thinking is. So, but yeah, I think it aligns with what you're saying, or it does align with what you're saying. So
thank you.
No worries.
Tremendous. We had one more question come in. Can Modla utilize or incorporate existing decision models, some of which are quite sophisticated? And sorry, my dog's going crazy in the background here.
So the answer is yes, but to answer your question in a little bit more detail, it depends on, well, it doesn't depend, it's yes, but it's where does it go? Is it decision logic that's quite complicated around the asset space, or is it decision logic that's quite complicated around the business process space? And what I mean by that is like if it's how your business runs, like if this condition, put it into this program, if it's had 3 maintenance activities in the last 5 years that have had this result, then do Y with it. That all sits in here in the solvers because it's related to your business and your business process. But if it's understanding what certain conditions and things must exist on an asset for its performance and things to change, that would live in this piece here. So at a high level, the answer is yes. The devil's in the detail, though, of where it lives. So
yeah, always. All right, Dane, thank you so much. And that brings us to the end of the questions. So thanks so much for your wonderful presentation today, Dane. It's been really informative, and some really good questions have come out of it. Thanks to Callum and Prith for being hosting the session today. And yeah, so please give Dane a virtual warm round of applause. Thanks to the 30 or so participants for your attendance today and your probing questions. And thank you to my colleagues, Blair Smith, Elisa Burke and Michael Thomas for bringing an awesome team to make these webinars happen. So we're actually taking a break in October, and we're not having a webinar in October. Our next webinar will be on the 24th of November, which is a Thursday. And the reason we're taking a break is we're not actually taking a break. We are undertaking the Knowledge Sharing and Collaboration Conference, and that's taking place on the 11th of October. The conference is jam-packed with high-quality speakers and important conversations. So if you haven't seen the information on that yet, we'll post that in the chat. We're using some technology in 3 live venues. So we've got venues in Traralgon, Frankston and Ballarat. And of course, there'll be online attendance available. And registration is via the Eventbrite link, which Elisa will post up in the chat. So don't forget to visit the Knowledge Hub, where this webinar and many of our past webinars are available, along with a plethora of information on many topics. So anyway, that's it from me today. If you need any further information, please drop Elisa a line at the IWN. Take care and have a wonderful weekend ahead. Cheers, everyone.
Thanks, everyone.
Thank you.
Thanks, everyone.
See ya. Bye.
Thanks, Dane. That was good, mate. Well done.
Thank you very much indeed. Thank you.
Thank you.